Welcome back to the weekly Tech Digest for week of June 21, 2026. This week we cover two topics, including thinking about high-quality human data and agentic content pipeline Instagram carousel. Let's get into it. High-quality human data is essential for effective model training and requires careful management of human annotation processes and the diversity of perspectives. High-quality data improves model training. Most labeled data is generated through human annotation, making quality assurance vital for effective machine learning outcomes. Human raters must be selected and trained carefully. Task design, rater training, and data collection stages are crucial for ensuring the quality of annotations. Crowdsourcing can yield reliable results if managed properly. Studies have shown that aggregated human judgments can approach expert quality with proper oversight and filtering of low-quality contributions. Disagreement among annotators can provide valuable insights. Some areas, especially subjective ones, benefit from diverse opinions, which can reveal richer information than a single gold standard. Diverse perspectives enhance annotation quality. Understanding and leveraging differences in opinion among raters can lead to a more nuanced understanding of data. What strategies can be employed to address the diversity of opinions among annotators in human data collection? The automation of content conversion from blog posts to social media formats reveals architectural insights and validation strategies for reliability and information density. The pipeline automates content transformation from blogs to Instagram carousels and YouTube Shorts. The system processes a blog post and transforms it into two formats, a 60-second YouTube Short and an information-dense Instagram carousel. Information hierarchy is crucial for Instagram carousels. Unlike videos, carousels allow swiping at the reader's pace, rewarding structured and standalone content cards over linear narratives. LLM hallucination is mitigated through strict validation of data. Bar and stat cards validate against the original article, demoting unreliable cards instead of dropping them to maintain deck stability. An adversarial review process identified critical bugs before code execution. Subagent-driven workflows allowed independent reviews that uncovered hidden issues, demonstrating the importance of context-free reviews. The development process consists of 4 key steps. First, write a specification. Next, create an implementation plan broken into discrete tasks. Dispatch each task to a fresh implementer subagent, and finally follow with an independent reviewer subagent. In summary, automation of content conversion streamlines the process from blog posts to social media formats, validates data for reliability, and independent reviews enhance stability. What other automation techniques can improve content creation processes in engineering? Adversarial attacks on large language models pose significant risks by evoking undesired outputs, challenging their safe deployment. Adversarial attacks mainly occur during inference. These attacks exploit fixed model weights to generate harmful outputs, making them particularly insidious in real-time applications. Token manipulation is an effective black box attack strategy. By subtly altering a small fraction of input tokens, this method can disrupt model predictions without apparent changes in semantics. Gradient-based attacks require full access to model parameters. These attacks leverage gradient signals to optimize inputs, showcasing the risks of deploying open-source models. Jailbreak prompting allows users to bypass safety mechanisms. This method relies on heuristic-based inputs to provoke unsafe outputs from the model. In summary, adversarial attacks mainly occur during inference, and techniques such as token manipulation and jailbreak prompting are significant strategies. Mitigating these attacks is crucial for the safe deployment of large language models. What strategies do you think are most effective in mitigating adversarial attacks on LLMs? LLM-powered autonomous agents can significantly enhance task execution by integrating advanced planning, memory capabilities, and tool usage. Task decomposition enhances task handling by enabling LLM-powered agents to break down complex tasks into manageable subgoals. This approach significantly improves performance on intricate problems, using a method known as chain of thought. Self-reflection facilitates iterative learning, allowing agents to utilize their previous experiences to refine their actions. This ongoing process significantly enhances the outcomes of future tasks, with React proving to be more effective than the Act-only baseline. Integration of different memory types plays a pivotal role in boosting long-term performance. By combining short-term and long-term memory, LLM agents can retain critical information over time, allowing for contextual inferences across various tasks. The chain of hindsight method improves output quality by providing feedback on previous outputs. LLMs learn to progressively generate better results by recognizing trends in performance improvements. When comparing algorithm distillation to other methods, AD is more effective as it improves learning from historical performance and quickly demonstrates in-context reinforcement learning, while other methods exhibit slower adaptation and limited utilization of historical learning. In summary, LLM-powered agents improve task execution through decomposition and self-reflection, while integrating memory types boosts overall performance. What are the potential ethical implications of deploying LLM-powered autonomous agents in sensitive areas? Effective prompt engineering is crucial for enhancing the steerability of autoregressive language models without updating their weights. Zero-shot and few-shot learning are basic approaches in prompt engineering. Zero-shot involves directly feeding the model the task text, while few-shot includes presenting high-quality example pairs to clarify human intent. Many studies looked into how to construct in-context examples to maximize performance. Example selection and ordering greatly affect model performance. Choosing semantically similar and diverse examples, while avoiding biases in order, can lead to significantly different outcomes in LLM responses. Choice of prompt format, training examples, and the order of the examples can lead to dramatically different performance. Instruction prompting improves model alignment with user intent. Instructed models fine-tuned with high-quality instruction pairs enhance clarity in task requirements and reduce token usage. The benefit of instruction following style fine-tuning improves the model to be more aligned with human intention. Chain of thought prompting benefits complex reasoning tasks. Generating reasoning chains through COT prompting helps large models tackle complicated tasks more effectively. The benefit of COT is more pronounced for complicated reasoning tasks. Focus on example selection and ordering, as it greatly affects outcomes. Instruction prompting enhances model alignment with user intent. Chain of thought prompting aids in handling complex reasoning tasks. What specific insights have you gained from your own experiences with prompt engineering? The latest enhancements in transformer architectures significantly improve their efficiency and adaptability. These changes enable better management of longer contexts and support a wider range of applications. Longer context handling is improved in new transformer variants. Techniques like context memory and distance-enhanced attention scores allow transformers to effectively manage longer sequences. Adaptive modeling techniques have been introduced, such as adaptive attention span and depth adaptive transformers. These methods provide flexibility in resource usage based on task needs. Efficient attention mechanisms reduce computational costs. Sparse attention patterns, such as fixed local and stritted contexts, allow for quicker computations by focusing on relevant tokens. Rotary position embedding enhances relative positional understanding. ROPE uses rotation matrices to incorporate positional information dynamically across layers, improving model performance for sequences with varying lengths. In summary, the latest transformer enhancements improve context management, provide adaptive techniques for flexibility, and incorporate efficient mechanisms to lower costs. What are the potential implications of advanced transformer architectures on future AI research and applications? Optimizing inference for large transformer models can significantly reduce memory usage and increase processing speed, making them more practical for real-world applications. Knowledge distillation can create efficient models. This method allows for a smaller student model to be trained by emulating a larger teacher model, thus maintaining performance while reducing resource consumption. Distill BERT reduces parameters by 40% while maintaining 97% performance. Quantization helps in reducing model size. By converting model weights to lower precision, models can achieve significant memory savings and performance improvements. Only quantizing weights to 8-bit while keeping activation at full precision achieves better results. Outlier handling is critical in transformer quantization. The presence of large outlier values in model activations complicates quantization and can lead to significant performance drops if not addressed. The scale of activation outliers can be about 100 times larger than most of the other values. Mixed precision quantization can reduce performance loss. Applying different precision levels for activations and weights optimizes the trade-off between model size and output accuracy. Mixed precision quantization combines 16-bit and 8-bit quantization for different parts of the model. To summarize, optimizing transformer models can drastically save resources while enhancing speed and performance. Knowledge distillation and quantization are two crucial techniques in model optimization. Additionally, addressing outliers ensures better performance in quantization. The Neural Tangent Kernel, or NTK, provides critical insights into why neural networks can converge to global minima despite over-parameterization during training. NTK explains the training dynamics of neural networks. It describes how a small change in model parameters influences predictions for other data samples during gradient descent updates. NTK helps to understand convergence in over-parameterized networks. Infinite width networks lead to deterministic convergence. The NTK's behavior can be characterized such that wider networks consistently converge to a global minimum regardless of initialization. The article emphasizes the theoretical improvements when using infinite width models. The article elaborates on how deep neural networks exhibit behaviors akin to Gaussian processes in their functional outputs. The relationship with Gaussian processes offers a probabilistic interpretation of neural network behavior. The gradient descent process using NTK involves defining the empirical loss function, computing gradients with respect to model parameters, and describing the evolution of model outputs using the NTK. To summarize, NTK aids in understanding convergence in neural networks. Infinite width networks enable deterministic outcomes and offer probabilistic insights from their relationship to Gaussian processes. How do you think the insights provided by NTK can influence the design of future neural network architectures? That's everything for this week's digest. Links to every post are in the description below. Drop a comment. Which topic did you find most useful this week? I'll see you next Friday.